Optical illusions show the difference in what your eyes can see and what your brain comprehends.
They show how your brain will often fill in things that make sense from previous experiences.
Even if it is not always exactly how your eyes are receiving the information. The beginning of the visual system starts with the eye. The cornea, which is a clear protective layer over the eye, is what light travels through first. Next, the light goes into the pupil, whose size is regulated by the iris, a colored muscle that opens and closes to allow the correct amount of light through. After that, the light travels into the lens, which helps focus the light onto the retina. Finally, the retina, which contains photoreceptors like rods and cones, collects the information and sends it to the optic nerve, which will then carry the message to the brain to process.
The part of the brain that processes information relating to your eyes is the primary visual cortex located at the back of your brain. This receives the information directly from the eyes. Also, the occipital lobe is involved and processes the information and senses things like depth, motion, and color. The temporal lobe is responsible for pattern and object recognition.
In this illusion, square B looks much lighter than square A, but they're actually the same color. From previous experiences stored and processed by the frontal lobe, our brain knows that shadows make objects look darker than they actually are. The occipital lobe in our brain interprets the shadow over square B to be darkening the true color of the square, so our brain recognizes it as a lighter shade of gray. Here you can see the illusion being assembled, and it proves that the squares are the same color but appear not to be because of its surroundings.
In this illusion, the gray lines in between the lines of white and black blocks look crooked, but they are actually parallel. They look crooked because the temporal lobe of our brains is trying to find an orderly pattern to break them into vertical bars. The crookedness is very noticeable if you look at a single square and only see the rest of the illusion through your peripheral vision, which is less reliable. Your brain tries to compensate for that by breaking the image into what it is perceiving as orderly straight bars.
In this illusion, you can clearly see a white triangle in the middle of all the other shapes, even though there's not an actual line to outline it. Our eyes are perceiving the pieces of shapes that are there, and the temporal lobe in our brain ignores the gaps in the other shapes and perceives the white triangle in the middle to create a whole image rather than just broken parts. Although there is no actual line outlining the triangle, the brain makes it clear in an effort to see a cohesive whole image rather than unfinished shapes.
This illusion seems like the inner circles are moving, but everything is actually stationary. This illusion can be explained by two things. The first is what is called an involuntary eye jitter. This causes your eye to move rapidly and make things you are seeing appear to be vibrating, moving, or in this case, spinning. These eye jitters are caused by the contrasting colors and placement of overlapping semicircles. Your eyes try to make sense of the 2D illusion by seeing movement instead of a bunch of stationary objects. Another cause of confusion in motion detectors in your visual cortex. The colors and the position of the shapes detected by the rods and cones in our retinas make your visual cortex think that it is detecting movement.
Similar to the checkerboard illusion, the bar in the middle looks like it goes from light to dark in shades of gray, but if you take out the bar, you'll see it's all one color. Your brain once again sees a shadow, and its darkest point is on the left. The occipital lobe in our brain interprets the shadow over the left end of the bar to be significantly darkening it, so you then recognize it as a lighter color, even though the photoreceptors in your eyes see the correct color. The brain overrides this in order to make sense of the illusion. As the shadow seems to lessen towards the right, your occipital lobe then does the reverse, so the right end of the bar looks much darker than the left. When you take the bar out of the illusion, you can see it's all one color. As shown by many different optical illusions, the light that our eyes receive might not be what we truly see after the information is processed in our brains. Sometimes our brain uses previous experience and knowledge to distort the image, or be confused by overstimulated photoreceptors because of colors and placement of shapes.